Okay, so as you can see, the topic for today is IP routing overview. Okay, we are not going to go with some in-depth topic because there are few basics that we are starting with, and then we will go up and discuss individual protocols. Okay, now first thing, what do you understand by routing protocols? Okay. So till now in the CCNP enterprise, all we discussed was related to switching technology. Agree? Switching, which deals with MAC address. And what does it switch to? Switch connects to multiple end devices. So on a basis of MAC address association, they switch the packet from one host to another host. Let's say they are in different. Yeah, I got just disconnected. So am I audible? Okay, great. Okay, and I believe you guys can see my screen as well, right? Okay, okay. Well, so I was talking about the switching that we discussed so far in the CCNP enterprise. It was all related to host communication over on MAC address. Okay. Now, from today, we will go ahead and we will see what is routing or switching of packet and where do we use this. Okay, so basically routing is seen across on the core layer. Okay, so let's say I have multiple ISPs. Okay, I have my office here, let's say it's in New York, and I have anything, yeah, let's say my users who wants to browse across to internet. So basically his traffic will reach our edge router, and the edge router will switch the packet, and the packet will flow one ISP to another ISP, and let's say it hits google.com server. Okay, so the packets are getting routed from one router to another router. There are couple of routers on this path. Okay, so it's all dealing up with IPs now, IP address. Okay, well, so in order to communicate between two routers, so let's say this router is placed in US, and let's say we have another router in India, and let's say we have a office or a enterprise. Okay, and in between there will be hundred of other routers. So from one router to another router there must be some communication enabled. Okay, so that is what we are going to go, that is what we are going to go through in the class today. So there are multiple ways of communicating. So let's say we have a simple option of static routing. Agree? I just define my destination. Let's say one of the network is behind this router 2, 1.1.1.1. And from this point of view, if I want to send any packet to 1.1.1, I can just write a CLI command that my packet has to go over on R2 and then let it go to 1.1.1. So that is static routing, something which you define manually in order to communicate between different networks. Okay, it's all dealing and it's all over on the routers now. It's we are talking about networks, different networks. Okay, so they don't belong to one single LAN now. They are like in a WAN connectivity, or let's say from one region to another region, the all your packets that you switch from one point to another point, it's all over on router now. Okay, so we are in a core layer now. We just so far we were all discussing about the distribution layer and the access layer point of view. Now we are going across through WAN, core. Okay, all your BGP, all these things will come across from today's class. Okay, so in order to communicate between two different routers, or a group of routers, there must be some protocol enabled. Okay, so basically we divide them into two segments. One is called as EGP, which is Exterior Gateway Protocol. And the other one is IGP, which is Interior Gateway Protocol. So where do we see these two of them? Let's say I have my LAN connectivity. Okay, I have a edge router, core switch, access layer switch, and access layer switch connected to multiple computers. So this forms a LAN segment. Now let's say an edge router is connecting to an ISP. Okay, let's say this ISP gets connected to another ISP and so on, and then they go and terminate on another branch office or something. So we have similar setup over on there. So this is also a LAN part. So who is connecting to different LAN segment? It's your WAN, wide area network. Okay. So over on the WAN, we are going to make use of EGP protocol, that is Exterior Gateway Protocol. Okay. What is an example for EGP? It is this Border Gateway Protocol. So you will be listening me calling up BGP term whenever I'm talking about the ISPs or the connectivity between internet and our edge router. It's all BGP running over here. Now, where is IGP running? Okay, IGP is running over here. And what are the examples like OSPF, RIP, EIGRP? Okay, these are some of the examples for IGP. Now, there is one more protocol that's called static. Now, that is also part of IGP, but yes, that's static, and these are called as dynamic routing protocol. So these are all the terms that we deal with the router or routing a packet. Okay. So what happens is, let's say this user, if he is typing google.com, so what happens is his packet will go to the switch. Switch will do the switching work. It will just pass to the gateway. Now let's say the gateway is here. So it will hit the gateway. Let's say this has some routing enabled, like one of the routing enabled, let's say OSPF. So it will see which is the existing path. It will send to the edge router. Edge router will have the ISP connection. Let's say it's having a ISP connection with AT&T. With the help of BGP, it's going to send to ISP1. ISP1 will send it across to ISP2 and so on. And then they finally reach the google.com server. Okay, so it's all about routing. So routing or the protocols are used to communicate between one router to another router. Okay, they must learn something. They must learn on which destination you're trying to send the packet, because this host name will be uh, resolving to some DNS IPs or to some IPs. Okay, let me show you what exactly I'm trying to say. So if I open up CMD, if I type NS lookup, so all these host name are getting resolved to some IPs. Okay, so from my laptop point of view, if I'm uh, either pinging google.com or if I'm trying to access google.com, it's nothing but from my PC or my system, my packets are trying to reach this IP. Now this IP can be anywhere, which I may not know. There might be that can be in US, and I being in India, from my laptop the packet has to travel along. Okay, and who is forwarding this packet? It's your router. Okay, there are routers, and similar way these routers, they need to learn some protocols, or they are enabled with some protocols so that they can understand who is the sender, who is the receiver, and what is the content of my packet, right? So basically if I ping this IP, what would be the content? Content would be a ping packet. If I do a trace route of, or if I try to do a telnet, or if I do try to do SSH, now what will be the data? Data will be one of them. If I'm trying to open www.google.com, now what is the packet? It's your HTTP. Okay, so your HTTP is responsible for carrying the data or taking the data. Now these data need some medium to travel across one router to another router, and that is what where we are going to enable the routing protocols. Okay, so over on WAN, it is your EGP, and the best example for EGP is BGP, Border Gateway Protocol. And within the LAN, okay, within the LAN, we have some IGP protocols. And the best example for IGP is RIP, OSPF, EIGRP, and static route. Let's say static route is also one of the IGP. But the drawback of static route is you have to manually define the routing. Okay, so it is okay when you have 10 to 20 manual configuration, but let's say you have 10,000 of routes, or you have 10,000 of users, and every users need to connect to internet, right? Now that is where you will not be in a position to write 10 manual lines of static point, right? So let me tell you what I'm trying to say. Let's say I have users here. Okay, these users are connected to access switch. Access switch is connected to a distribution switch, and a distribution switch is connected to a router. Okay, and the router is connected to ISP1. Let's say the ISP1 connects to ISP2, and then it finally reaches google.com. So do you think I will write a individual routing for user 1, and similar way should I write another manual static route for user 2? I cannot do that, right? It's a manual work. Now let's say if this user is uh, switching the job, now I have to manually delete that as well. Now that is not a feasible option in enterprise, because in enterprise users might be more than 500, right? So for that reason we will go with dynamic routing protocols. So what happens in dynamic routing protocols are they have some inbuilt mechanism. Let's say they have some inbuilt algorithms. Okay, so each protocol, let's say EIGRP or OSPF or RIP, they have some internal algorithms, and based on that they will auto calculate which is the best path to go out. Okay, so the intention of this protocol would be to push this packet to ISP. That is the main work of IGP protocol. They receive something from the user, and now they have to push it to outside. Now which is the best path? Okay, now the example is again something very on our day-to-day life. Let's say if you are traveling from point A to point B. Okay, you have various means to travel. You can take metro, you can board a bus, you can board a train, or whatever. But what is the main factor? Cost is the main factor which will decide which medium are you going to take, right? So let's say you have multiple medium to reach from A to B. One is charging you $1,000. The other person or other medium is okay. So there was a slight latency. I guess that's fixed. Okay. Yeah, come back to this example. Let's say from A to B, it is charging $1,000. Let's say the same distance is charging you $500. And then there is one more way to reach the point B with just $10. Now, which is the best one that you will adopt? You will adopt this one, right? Similar way, when you have multiple routing protocols, EIGRP, OSPF, RIP, or static, now the packet is confused, right? Packet is confused whether should I follow what EIGRP is asking me to do, or should I follow OSPF, or should I follow RIP. To make this uh, more easier, to make the decision more easier and predictable, we have certain steps, predefined steps. Okay, now let's say if there are multiple routing protocols enabled, which one would be the best taken up here? Okay, so those are few things which we will go ahead in and see what in today's class. Okay, so this was just an overview which I thought of giving to someone who is first time for networking courses. Okay, well, so let's talk about first the mechanism of these protocols. Okay, so let me open up the slides or the notes. Okay, so this is all the primary definitions. These are the routing protocols. Okay, so ISIS is also one of the IGP protocol. Okay, so when I just said that there are two protocol, one is EGP and IGP. So under EGP we have BGP. Okay, and under IGP you have OSPF, ISIS, EIGRP, and RIP. Okay, but we don't use ISIS inside enterprise. This is used in service provider. Okay, ISIS and OSPF are very similar. Both are link vector protocol. Now I'm going to tell you what is link vector protocol and all those things, but just understand the way OSPF work inside enterprise. The very similar way ISIS also works inside service provider. Okay, now who is service provider? Like your AT&T, Vodafone, you have plenty of service provider, right? So inside their LAN segment they need some routing protocol, and that is ISIS. Okay, now they don't use OSPF because of certain reasons. They prefer ISIS. There are a lot of similarities and there are a lot of dissimilarities as well between these two protocols. Okay, so ISIS is not a part of CCNP enterprise, but we have OSPF in depth inside CCNP enterprise. Okay, so that was few protocols that router will support, and as per the placement of router, if let's say router is placed in EGP or exterior, when there are multiple ISP intervention, now you will use BGP protocol, border gateway protocol. Okay, when you're using routers inside LAN segment, okay, inside a LAN segment, you need some routing protocol which are very faster and which can calculate the new path. They can reconvergence. If a primary link goes down, they have the second link coming up as a primary. So they need very faster. BGP is not a faster routing protocol. Okay, this is not a faster routing protocol. You have EIGRP and OSPF, which is very faster and which is used for multi-routing, or when you have lot of routings inside your LAN segment. Okay, when the reconvergence plays an important role, so we make use of this IGP protocol. Okay, now regarding to autonomous system, why I have this slide for autonomous system is because let's say I have a LAN segment or a LAN or a enterprise, okay, with a core routers, distribution switch, access switch, and the host. Now this core or a edge will be connected to some ISP. And where am I running BGP? I'm running BGP here, and I'm running all my dynamic or IGP routing protocol within LAN segment. Now, BGP runs over on autonomous system. Okay. Now, what is autonomous system? So let's say this ISP belongs to one of the autonomous system. This belongs to another autonomous system. Okay. So basically autonomous system is a group or network. Okay. It's a network or group of network, which is controlled by one administrative group, right? Let's say this is ISP. Who is controlling this? The network engineers who are working in this telecom industry. They are basically handling the LAN part of this ISP, right? As a enterprise, let's say we are here in the enterprise level. So as a enterprise, I'm just drawing a cloud, and I'm just defining it as one of the AS. But those engineers who work on these service provider, it is very similar to your enterprise. They will also have their LAN segment where they are running IS, or they will have their own predefined policies, predefined routing protocols, right? So they form one administrative group, like how we form a administrative group, and how we will be making use of one of IGP protocol, right? So let's say if I'm using EIGRP, now I will set up certain policies or certain routing protocol within my enterprise. Similar way, they will have their own administrative policies, right? So each one falls to one of autonomous system. Now, who gives the autonomous system number? It's your INA group. Okay. These are online entity which is responsible for IP address allocation. They are also responsible for port number allocation and also AS number allocation, autonomous system. Okay. So these are predefined. Now, if you just go and Google up for INA AS or port numbers, you will get all the AS numbers. Okay. Domains, numbers. Okay, let me search in Google. Okay. ASN. So these are the ASN, or these are the autonomous system. Okay. The few ones are reserved, and the few ones are given to public ASN numbers, or so basically your INA groups are going to assign the AS group. Okay. So I'll just give you one more example. Let's say this as an example. Okay. We have Facebook over here, and we have Microsoft over here. Now this forms a AS number, a complete autonomous system, which have collection of routers which are following some standard protocols. Now that protocols are within this autonomous system. It's not required that Facebook is using EIGRP. Now even the Microsoft use the same thing. Microsoft can use their own policies, their own routing protocol, right? So that is AS number, autonomous system, and autonomous system is used specially in the BGP protocol. Okay. The reason is BGP is dealing with your WAN communication, right? So what do we have here? We have BGP running here. Okay. And all these are with respect to AS number. So we have one AS number, the other side will have AS number. When we are dealing with the dynamic routing protocol like OSPF or EIGRP, I don't need to bother about AS number, okay, because my protocol are within my LAN segment only. So these protocols are not taken outside. These protocols are just used for these user traffic to send to the core, and the core will then take it to the ISP with the help of BGP. Okay, so OSPF is like intermediate protocol from the user point of view to take it to the core router, and then core router will be connected to some WAN circuit, AT&T or Vodafone, and then it will take it further. Okay, so that was regards to, a little bit on AS or autonomous system. So as you can see, there are multiple LAN segment. Okay, I have a LAN, the complete LAN segment. I have another LAN segment. I have one more LAN segment, and this collectively with all the three layers, my internet provider, my service provider has given me autonomous system. So basically, autonomous system is between 0 to 65535. Okay, but valid is starting from 1. So who is going to give me this autonomous system? ISP is going to give. So let's say I have a connectivity from AT&T. So my AT&T, when I'm taking up or when I'm buying up a new link, the ISP is going to give me the autonomous system, the public IPs and the subnet mask for which I'm going to pay. Okay. And how do I communicate? Let's say this is a head office. This is a branch office in some other location. I have one more branch office. Okay. Now I need some protocols which can communicate all these three uh, offices for me. Okay. So let's say on head office, as a LAN protocol, I'm making use of OSPF. Rest I can just make use of EIGRP. Okay. And also if you see, BGP has two flavors. Basically, BGP comes with eBGP and iBGP. Okay. So where is eBGP used? eBGP is used between two different LAN. Okay. Between two different LAN, I am making use of eBGP. And as a dynamic routing protocol, I am making use of OSPF and EIGRP. Now, why is iBGP used? Okay. So do you think iBGP will do the work of EIGRP or OSPF? uh, well, exactly, it will not do that. Okay. IBGP is specially used for your path manipulation. Now this is again advanced topic in BGP topic. Okay. So what is it doing, or what is it going to help us is, let's say in the future classes when I have two routers, first router connecting with first ISP, second router connecting with second ISP. Now, you might have heard a lot of interview questions where the interview tries to give some scenarios that we want 1.1.1.1 to be taken up on this path. Okay. So you might have seen the interviewer giving you an scenario saying that we need this network to be taken up on ISP1 and we want this network to be taken up on the ISP2, right? Now, in such scenarios, let's say you're doing some kind of path manipulation. Okay. So you're trying to enter some additional commands within these BGP routers, which are directly connected with ISP. Now, who is going to carry the manipulation packets between these two protocols, right? So there should be some mechanism. So let's say if something comes over here, okay, because of this mechanism, it says that, okay, so there is some additional uh, policies added on this and I need to take up this path. Okay. So that's because of your IBGP. IBGP is helping us on path manipulation. Okay. But IBGP is not a complete dynamic routing protocol. You still have to make use of OSPF. You still have to make use of EIGRP or all the interior gateway protocol. Okay. So these protocols are different, okay, inside LAN. And when if you see IBGP, the purpose of IBGP is different. Okay. They are not for dynamic routing. They are used for the path manipulation. Let's say there are multiple ISP. If you want to send so many prefix on first ISP and so many prefix on the second ISP, you need to do some changes on your routers. You need to add some additional commands. Okay, there are many path attributes like AS path, wait, local preference. Okay, now these additional commands will be put up inside this router, and whatever parameters you're going to set for these values will be propagated with the help of IBGP. So that is the main purpose of IBGP. That is why this diagram shows IBGP, because in case of any kind of manipulations of the path. Okay. So yes, so this is AS, and this is how we define or we configure BGPs. Okay. So we have proper BGP session. This is just a overview of routing. So you will be seeing a lot of things today, but then in the next class we will go up with one individual protocol and we will cover up it in depth. Okay. Well, now regarding to the vector. So as I told you, these IGP protocol, okay, so they are multiple of them. Let's say I have RIP, routing information protocol. Similar way, I have EIGRP, Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol. Okay. And one more is OSPF. These are the three IGP which we use in enterprise. Okay. So you need to remember few words here like enterprise, service provider, data center. So the course that we are dealing is with respect to enterprise, not with service provider, neither with data center. So that is why we are discussing all the protocols with respect to enterprise. So in future, if you come across ISIS or if you come across Fabric Path, don't blame the instructor that instructor has not covered this in the CCNP. You must know there are CCNP for every tracks like service provider, data center, enterprise. So each track will have its own protocol in depth. So if you take service provider, you will see a lot of ISIS being discussed. If you take data center, then you will see all the Nexus boxes, Fabric Path, and all other protocols. Okay. In the enterprise, these are the protocols that we are going to check it out. OSPF is open shortest path forward. Okay. So these are the three dynamic routing protocol which we use in the LAN part, local area network. And each protocol have its own mechanism that it works on those mechanism. Okay. So the first one, which is called as distance vector, is an example for RIP, and RIP is almost obsolete from the market or the network industry, because this is one of the oldest routing protocol, might be from 1980s, and it has lot of issues, and the way this routing protocol works is not a very intelligent or not very smart way. Okay. So you will not see RIP used in enterprise, yes, but you will see this protocol still getting used in some of the government based offices. Okay. Some pretty old offices, 10-15 years old, where the network is just for one or two users, might be they are still making use of RIP, but on any other enterprise with at least 50 plus users, they are not going to use RIP. Okay. They will either go with EIGRP or OSPF. And in our CCNP enterprise, we have these two in depth, not RIP. But I'm just going to cover this from point of interview. If someone asks you, you just need to know a basic foundation of RIP. Okay. So let me tell you what is distance vector. Okay. So the example for distance vector or the protocol that will run on distance vector is your RIP, routing information protocol. And how it works is, let's say I have a router which is connected in a single line. Okay. Let's say I have to send some packet from router 1 to over here. Let's say this is 10.10.10.10. And let's say this is 1.1.1.1. So the packet is just routing from one router to another router. Okay. And it finally reaches over here. Now, the drawback here is if you just analyze this packet will not know anything about its past router. Okay. This packet will only know that I have two more hops to reach the destination. Okay. So what is a loss here? So this packet is ignoring all the other factors of these. Let's say the cost factors. Let's say the bandwidth factor. Now let's say there was some serial link in between. Okay. But for a RIP, it's always shortest path to reach. So let me show you what exactly is that. Okay. So if you take this as an example, so as I was telling, if I have to travel from A to B, I will pick up a shortest distance, or I will pick up the shortest cost from A to B. Okay. So RIP works blindly. That means, let's say if I want to advertise some packet from R3 to R7. Okay. I have two ways to reach here, or I have three ways to reach here. Let's say 1, 2, 3, and 4. I also have one more path. So let me make use of another color. I can also travel in this direction. Similar way, I also have the third path, that is to R1, R2, and then R7, right? Three paths. Now, which path is by default RIP going to take? It's going to take the shortest path, and the shortest path is this. Now, what is the drawback of using this path? You're going to make use of some serial link here. So if you see, this is a notation of serial link. Rest are all, let's say they are a giga Ethernet links, which are high speed. And what is serial link? It's just a 64 kbps link. And what is RIP going to do? As per your blind algorithm, the shortest path to reach, it just took up this path, that is R3 to R1 to R7. So do you think in this 2020 generation, we will go and adopt this kind of link for any kind of packet transfer? No. Okay. We all are at least looking for giga Ethernet. Okay. Even your fast Ethernet is now outdated. Okay. So how is the Ethernet medium? It's Ethernet, fast Ethernet, giga Ethernet, and then you have all your 10 giga Ethernet and all such. Okay. So your Ethernet is just 1 to 2 Mbps. Fast Ethernet is 100 Mbps. Giga Ethernet is 1 Gbps. 10 is nothing but 10 gigabit per second. So these are how the technology has evolved, right? Now you cannot just rely on serial link. Now that is a drawback. If you have like 10 users, or let's say you at least 2 to 5 users, your network is all choked up because of the less bandwidth here. That is one of the major drawback of RIP, because RIP doesn't do a smart calculation. It is a blind. It just see the path and it's just adopted. It is not even checking that the speed of this link is low. I should not take this. At least I can take this because of its high speed, or I can take up this link which is even better with very less hop counts. Okay. And the second drawback of RIP was it only supports 16 hop counts. That means, let's say if this packet is traveling from one router to another router, once it reaches 15, again, the next packet will be dropped. So that's a drawback of RIP. So it cannot be used in a very large enterprise. It's just a foundation routing protocol. Okay. And there are very less companies which use RIP. So what is distance vector now? Distance is nothing but the shortest path. Vector is nothing but on which direction or which interface is your RIP preferring. Okay. That is why we call RIP as distance vector. And which algorithm does they use it, or who has discovered this algorithm? So they make use of Bellman Ford or Ford Fulkerson. Okay, so these are the scientists who have discovered RIP. Fine, and rest are the same. To have the loop free path, all those things are good. Okay, but when it comes to large scale enterprise, your distance vector or RIP is not effective. Okay, so it's a drawback for us. So later on, there was a new protocol or a new vector algorithm discovered, which is called enhanced distance vector algorithm. An example for this is EIGRP, another dynamic routing protocol. Okay, so this works on this algorithm, diffusing update algorithm, which is also called as dual. It's a enhanced distance vector algorithm. Okay, so it uses shortest path to reach the destination. Okay, so every routing protocol has the same motive, to take the to take the packet and to send the packet outside, but it should make use of the shortest path, or the shortest path, okay, or the least cost to take to the destination. That is the main intention of these routers which are running the protocols. Okay, so as it says, it will take the shortest path to reach to the destination. So these are few important advantage of EIGRP. It's very faster. Okay, let's say if I have couple of routers. Okay, so I want to reach this destination. So I can go in this direction. I can also go in this direction. Now let's say if my primary link is down. So how fast is my second or the backup link going to take up the packet and send it to destination? That is a convergence timer. Okay. So EIGRP is very faster because it has multiple terminology like feasible distance, all those things. So we will discuss that. They are nothing but the second backup, or see, let's say each, or let's say EIGRP will have one of the best routing protocol placed inside routing table. Now the next best will be also available. Now let's say if this goes down, you will have this coming up inside routing protocol. Okay, so that's why it's concluded as a rapid convergence. It sends update when there is network change. Otherwise it's not going to send any full routing information, and not going to uh, increase the overhead on the routers. Okay, whenever there is change in the network, the router will send the updated content, not the full content, and it's going to synchronize. It uses hello to have the neighborship relation. Okay, so if let's say there are a couple of routers, so how do they come to know that router is up or dead, right? So there will be some hello packets every seconds. How is the cost calculated? Okay, as I told you, in the case of RIP, what was the cost? It's nothing but your distance or hops. So your hops was contributing to your cost. If you have so many routers, let's say 1 2 3, so the cost of a RIP used to be 3. Okay, if you had multiple routers, then you just increase it 5 hops. Now in the case of EIGRP, the formula to find cost is different. Okay, and the cost now will depend on multiple factors. It's going to depend on bandwidth, delay, reliability, load, MTU. Okay, it's not just going to count hop count as in RIP, which is a drawback and why RIP is out of the market. Okay, in case of EIGRP, your interface bandwidth, the delay, the MTU size, the load, everything contributes to the cost. Okay, so let me show you one of the example of EIGRP. Let's say I have this. Okay. Now EIGRP is smarter in case of finding the best path to reach destination. Okay. Now as in the case of RIP, it's not going to send this because it's just 2 hops, right? It's not going to use that because your bandwidth is more here. If you see, the bandwidth of this link is more, and if you see the bandwidth of every link, okay, so it's 2816, 2816, 816. So if you see this path, it's good. If you see this path, it's okay. So there is one more path over here, okay, which is 2816. So best preferred is this, second preferred is this, and this is the least preferred, or I say third preferred, okay, because the cost formulae for EIGRP will calculate the cost of the packet which has to reach this. So let's say if a packet is ready, okay, and it's going to see there are multiple ways to reach. Now the EIGRP is going to calculate the cost, and it's going to say better take this path because it's going to cost you only so and so. Now the packet will take up that, okay. So that's how. And where will be all this information? This information will be in the routing table. So if you open a routing table on any router, every destination, okay, there will be the cost next to the destination IP. So let's say the cost here is 1000. Okay. So basis on the best route selection, let's say out of 3 routes, the best will be put up inside routing table. Okay. All 3 are not going to come and fit inside routing table. It's only one best route. Now let's say if this goes down, then the second best route will automatically come and get placed in routing table. Okay, so you must know that routing table is something which have only the best route. All your next backup or the least backup is all outside the routing table. If the primary goes down, then it will be pulled up. Okay, so every every route to the destination, there will be only one best, which will be attached to the cost value, also something called as AD value. So we'll discuss that, what is administrative distance. Okay, so these two values will be tagged with this IP or this destination IP. Okay, and that's how your packet will make the decision of traveling on this path. Okay, so that's a little bit summary of EIGRP. It's also called as hybrid routing protocol. Okay, because it has a behavior of distance vector and link state protocol. Okay, so little bit overview on each algorithm. Okay, now coming to the link state algorithm. Now, what is an example for link state? It's your OSPF as well as ISIS. So these two protocol are a part of link state vector or a link state routing protocol. Okay, as I have mentioned here, OSPF for enterprise and ISIS for service provider. Okay, so in the case of OSPF, we all know it's your LSA. LSA is like your components. Okay, and what is they going to do? Let's say I have multiple OSPF enabled routers. Okay, now as you have all the OSPF up, you have all the neighborship coming up. Now it's your LSA packet, link state advertisement packet, which will be taking all the network information. Okay, so every router will send the LSA to the next router which has OSPF enabled. So these LSA packet will carry the network information, network changes, network deletion, whatever you do uh, uh, in the normal day to day. Okay, so all the information of your links will be taken up by this LSA. So similar way in ISIS, it's your LSP, link state packet, which is going to do that work. Okay, so like how we have LSA in OSPF, we have LSP in ISIS, which is doing the work of the topology or update or the synchronization. Okay, and yes, these are few things which yes we will see in OSPF. Okay, the best route will be put up in the routing table which we discussed. Now what about the remaining routes? Right, so remaining route will be put in the database table of OSPF. So that's something here, link state database. So all the link information will be put up in this. So let's say the best route for some reason goes down. Now one of the route will be taken up from the database table and will be put up in the routing table. Okay, so that's how a normal uh, OSPF or any routing protocol works. They will have their backup ready, so they just will insert on the routing table whenever the primary links goes down. Okay. Okay, and what is the who is the scientist who discovered OSPF, or what do we call it as? It's called as Dijkstra Shortest Path First, SPF algorithm. Okay, SPF is nothing but the shortest path forward algorithm for OSPF. Okay, and regarding the overheads, basically link state are going to have more overheads. They are going to take more CPU and memory. Okay, so let's say I have EIGRP on one side and I have OSPF on the other side. Okay, now why is link state vector called as uh, taking up more CPU or more memory? The reason is, in the case of OSPF, let's say this router has few more networks. Similar way, this has few more network and this has few more networks. So in the case of OSPF, from router 1 point of view, router 1 will know every other networks, okay, along with its own network inside its linked state database table. Similar way, your other router, let's say R2 and R3, will also know each and every other router. So let's say if router 1 knows 100 of networks, R3 is also going to know 100 of routers, and R2 is also going to know 100 of routers. So basically they are having consistency in their database table. Okay, if something goes down, everyone is going to get notified that this is down and they are going to update. That's making it consume more CPU and more memory. In the case of EIGRP, that's not what is going to happen. Okay, EIGRP will only see what is connected to it. Okay, and similar way, they are not bothered, or they are not going to maintain the consistency. Okay, they don't maintain consistency. They just see who is having the least cost. Let's say if I want to travel this way or this way, it's going to see from that point of view. Let's say this is best, then it's going to just send to that, and then this router is going to see how to reach to the destination. This router will not take the headache of other uh, networks, or it is not going to install it inside EIGRP routing. Okay, so that's why these uh, these protocol like EIGRP, they are consuming less CPU or less overhead on the routers. Okay, so let's go further. Okay, so this is regards to OSPF. As I was talking, as I was telling about OSPF, if you open up the database table of R3, you can see the complete network which are behind these router as well. So from R3 point of view, you can see every links in your in your network topology. That's creating overhead. If something goes down, let's say if one network, okay, let's say one of the network over here, which is 2.2.2.2, is down. Now that information will be sent to every other person in the network, and there will be a lot of noise happening here. Okay, so that is why it's consuming more CPU, and we have the solution for that. We normally, in case of OSPF, we are going to scale them in terms of areas. Okay, we what we do is, let's make it as area 1, let's make it as area 0, let's make it as area 2. Now what happens is, if something goes down, it's just going to remain in this area. That particular topology change notification is not going to send to the 0 or 2. Okay, so there are way to reduce that, but as a default protocol, EIGRP and OSPF, EIGRP is very faster, it's having the better convergence power than OSPF. Okay, and it is going to consume very less CPU and all other things. Okay, initially few years back, EIGRP was considered to be a Cisco proprietary. Okay, might be like 5-10 years back, EIGRP used to be called as Cisco proprietary, and OSPF was called as open standard. But then what Cisco did is Cisco also made it as open standard. Now EIGRP is open standard. We can use it in Juniper. We can use it in any multi vendors. Okay, so it's open standard. So it's up to company which one they prefer. Okay, for a long term, for a enterprise with thousands of routers, OSPF is better because they can scale, and they can scale the traffic, the packets in terms of filtering. Let's say these LSA will have, so let's say there are multiple types of traffic in this. Some traffic coming from EIGRP, some traffic coming from different areas. Okay, now they are nothing but LSA. Like LSA, we will see the LSA type, like LSA1, LSA2, 3, 4. Now we can filter this LSA. I can say that I don't need LSA5 in this. Now that becomes more scalable in terms of OSPF, whereas in EIGRP I can't do that. Okay, so that is why these two protocol which are widely used has its own plus and minus. Okay, it depends on company to company where do you want to use this, and on what circumstances, or what is your network design, or how many users are you expecting in your enterprise. So basis on that you can deploy one of them. But as far as I know, OSPF is much more preferred than EIGRP. Also, from interview point of view, straight away interview ask you on which protocol you're good, either on EIGRP or OSPF. If you say OSPF, he's going to ask you questions only on OSPF. Okay, but yes, from the certification point of view, you just cannot ignore any of them. Okay, both are important because you never know, the question can be out of any topic. Okay, so just for certification, I'll take up both of them on the same weightage. But yes, from interview point of view, you have a privilege of opting for OSPF. If let's say you're good at OSPF, so you can just uh, expect the question, or you can just tell the interview that I'm good at OSPF, or I am having enterprise which runs over on OSPF. So basically they'll ask on that. Okay. Okay, coming to the last algorithm, that is path vector algorithm. Now this is very similar to your distance vector. Okay, so which routing protocol was an example for distance vector? It was your RIP. So do you think RIP and BGP are same? No, they are not same. On what basis are they not same? Okay, let's see. So in the case of path vector, which is very similar to distance vector, the difference is that instead of looking at the distance and determining the best loop free path, BGP will see the BGP path attributes. Okay, so that's something advanced topics in BGP attribute. Okay, so let's say I have couple of routers. Okay, so this is my ISP. Let's say this is connecting to ISP1. Okay, and I have other ISP, two ISPs. Okay, so what is a behavior of RIP, which is an example for a distance vector? It is just going to send blindly depending upon the shortest path. So let's say, okay, let's say this connects to another ISP, ISP3. So your RIP would have sent in this direction. Okay, it is not going to see on which link is it connected. Let's say this was a serial link. The RIP would have considered this. But in the case of BGP, okay, I have some attributes, BGP attributes. Okay, I can say that I don't want to use this, so I can just manipulate the behavior on this router. Okay, there are manipulation attributes like AS path, weight, local preference. Okay, so basis on these attributes which I can set it over here, I can say let's ignore this as of now. Okay, I'm not going to block this, but I'm going to ignore this, or I am going to keep this as secondary. Okay, because I'm after all paying some amount to these people, ISP2. So I don't want to keep them off. Okay, that is not my intention. If I would have kept straight away off, then I don't need to deal with any path attribute, because by default your packet will take only the up interface. Okay, but in my case I don't want to turn it off because I'm paying some amount, so I just want to keep it as a backup path in case sometime if this goes down, I still have a backup path for my redundancy behavior, right? But I need to manipulate the behavior. I want my traffic should go over on this, and I need the traffic coming back over on the same path. Okay, now that is what is your BGP inside path vector, making it different than the distance vector that is used in the case of RIP. Okay, yes, these are the path attributes like AS path, MED, multi-exit discriminator. We have local preference, and yeah, and there is one more which is called as weight. Okay, so these are some attributes. So basically there are like 15 to 16 attributes. Okay, so we will see them when I'm taking up the BGP class. Okay, so the path vector guarantee loop free path by keeping a record of each autonomous system. Okay, now regarding to the looping, which we also have seen in case of switching. Okay, so in the case of switching, it was called as uh, switching or a layer 2 loopings. Okay, and what is the mechanism to have a loop free environment? It was your spanning tree. So spanning tree is a mechanism to avoid loop. Okay, don't think that spanning tree is something which will bring the loop. Okay, it's mechanism to. Okay, okay, so just a minute, guys. Okay, anyway, I have the second recording going on, so that's fine. Yeah, so as I was telling, okay, regarding the loops. Okay, so in the case of switching, it's your spanning tree which is avoiding the loops or a loop free environment. Okay, in the case of BGP or these all these routing protocols that we learned, so every routing protocol will have its own mechanism to avoid loop. In case of BGP, so in case of BGP, what happens is, let's say I have this kind of topology. Okay, so my R1 or router 1 is going to forward or advertise this packet. So when this packet is getting advertised, it's also going to map or associate AS1 along with that packet. Okay, now it goes and hit to R2. R2 is forwarding that to the next router, but it's making sure it's adding its own AS number and the AS1. Okay, so this is how the packet that's traveling gets added up AS value. Okay, so it becomes 421, and now when R3 is going to return back that same packet to R1, R1 is going to exclude. The reason is that packet will have all the AS value 3, 4, 2, 1, and 1 is nothing but its own AS value. Now that's where your BGP will discard this packet. Okay, similar thing happens on this. If a packet went across from R3 to R2, okay, now there's chances to see the packet of 1, right? 3, 4, 2, 1, and it already has a 1 received from here. Okay, since this is having the more number of AS value than this, so this packet is also excluded. So this is how the loop free environment is achieved in the case of BGP. Okay, so your AS number are getting added up with each packet. So we will see about the loop free mechanism in eBGP as well as in iBGP. Okay, as I discussed, there are two flavors of BGP. So adding of AS path is in the case of ES or in the case of eBGP, right? So see, very simple logic to find out whether it's eBGP or iBGP. In the case of eBGP, it's external BGP. That means which deals with multiple autonomous system. Agree? So obviously it's going to call as eBGP. Now what is iBGP? The two routers, two BGP router, which are going to share the same autonomous system. Okay. Now there can be looping within this, and there can be looping happening within the whole topology as well, or between the multiple ISPs, right? So there should be some loop free mechanism. So in case of eBGP, we have AS path. In case of iBGP, we have a full mesh, which will help it, or we have route reflector. Again, some advanced topic which we will see in the BGP topic. These are just a overview of every protocol. Okay, so don't worry if you are not catching up. You can just go back and rewind this class. It's very simple, which you should be knowing from your CCNA part. Okay, from your CCNA point. So these are the few steps. That's what something which I described. So it says the same thing. Okay. Okay, now after checking out the first few part of protocol overview and autonomous system, the different algorithms for IGP, BGP. Now, what is the path vector, or what is the path selection? Okay, so that means so what I want to show you is, let's say I have couple of routers. Okay, let's say I have a network 1.1.1 which has to be sent to 4.4.4.4. Now let's say I am running on OSPF on all the links. Okay, I have OSPF here, I have OSPF here, similar way I have OSPF here, and similar way I have OSPF on the second side. Now which path will it take? Now that's something which we need to understand. Okay, similar way, let's consider I have RIP here, OSPF here, and EIGRP here. Now in this scenario, which path will your packet travel? Will your router forward the packet to this, or this, or this? Okay, these are few things which we have to understand. Okay, uh, then only we can start individual protocols on in depth, because these are something which are basic, but yes, you should know on how is your router going to make the decision, what are the factors for making the decision. Okay, so as we discussed in from the very beginning of the syllabus, how is router going to route the packet? So let's say I have a router. Okay, so let's say I just received some packet on fast Ethernet 0/0, and the packet will just go towards the routing process and come out, okay, over on F0/1. And what is happening inside? It's your different planes. So what do we expect inside router is we have two planes. One is forwarding plane, one is control plane. Okay. So any traffic which deals with your directly connected or a static route, okay, or your ARP packet, they will just take up this table, forwarding plane, forwarding information base, and just they will go out. But in the case of special packet, so what is the requirement for a packet to be called a special packet? Let's say if it is a routing or a dynamic routing based protocols. Okay. Now the packet will come over here. Forwarding plane will send it to control plane. Control plane is where you have all the routing protocols. Okay. That's also called as routing information base. And the packet will be sent back to FIB. Okay. forwarding information base, and then it will take the exit path. This is something which happens in the routing, and we have discussed this in the very beginning of the syllabus. Okay, and why am I talking this is because we need to understand this in order to discuss the path selection topic. Okay. Okay, so from my previous example, when I have multiple routers, which path should it take? So there are three criterias. Okay, longest match, administrative distance, and metrics. So these doesn't happen all three at once. It's one after one. Okay, if the criteria matches on the first point, your packets have taken the decision by now. Okay, let's say the longest match was a tie. Now it will go to the second step, that is administrative distance. If it has found out the way, it will be processed to the next router. If not, it will be sent to the metric. Okay, so each one of them is being discussed. Okay, so in the case of longest match, it's about your subnet mask. Okay, so the highest subnet mask is preferred always. So that means, let's say I have source router. This router wants to send some information to this router. Okay, but in between you also have couple of other routers. Okay, let's say you are sending something or to this network 4.4.4, which is a so this. Okay, so you just are forwarding some information from 1.1.1 to 4.4.4. Now you see there are three different networks. Now as per the first path selection, it's going to see the longest match. That means each path, or let's say the each routing protocol over here will have some advertisement. Let's say it is going to have 4.4.4.4 with 32 slash mark, or let's say 30 slash mark. Similar way, this path is going to have 4.4.4.4 with 28 subnet mask, and this is going to have 4.4.4 with 24 subnet mask. Right? Let's say we are having all these three routers. Let's say they are all running on OSPF. Okay, all of them running on OSPF. All of them have the same equal cost, but the network advertised are with respect to different prefix length. Now this is the first decision maker. Okay, and in this case, the highest one wins the election. That is, this is going to win the election when compared to 28, when compared to 24. The 30 is going to win the election. The reason is, if you just do a math, if you convert the IP, okay, let's say, how do we convert this to the binary format? It's very simple. You just need to know the conversion. Okay, so basically each IP block is written in terms of 255, 255, 255, and 255. Okay, and how do you just expand this or convert into binary is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and so on till 2 to the power 7. Okay, so if you just add up these value, it's going to be 255. Now 172 is one among this value. So if you just try to expand this value, okay, you are going to get this binary form. Or if you're lazy enough to do that, just make use of some converter. Let's say IP to binary. So you will find some online converter. Okay, so let's say what is the IP that I was discussing? 172.16.0.10, right? Okay, now if you just convert to binary, so this is the value that you get. Okay, and how do you get back to the decimal format? As I told you, 2 to the power 0, 2 to the power 1. So if you do this calculation, you can get it back to 172 and whatever 16, 0, and 10. Okay, very basic again, something which you learned in your engineering or might be in CCN. Okay, so when you just convert this to the binary format, this is what you get. And now regards to the prefix length. Okay, in case of 12, you just gray out or just highlight the first 12 bits. In the case of 18, you just highlight the 18th bit. Okay, so totally there will be 32, right? We know IPv4 is 32 bit. So if you just highlight them, which is having the highest matching length, it's your this prefix length. Okay, so in case if ever there has to be some decision maker, a decision should happen, so this is going to win the election. Okay, and in, let's say, in a practical way, let's draw that. Okay, so let's say I have this kind of design. Okay, so I have this put up over on this. I have 172.16.0/18 and I have /26. Okay, and if I'm forwarding some packet, now it's going to take this path because of the longest match. Okay, so this is the first criteria for your routing to happen, or the router to send the packet to the destination. It's your longest match that's get counted upon. Okay, let's say they are all the same. That means we are just advertising /24/24 and /24. Now in this case, they are going to be a tie. Now what is a tiebreaker? I need to find the administrative distance. Now what is administrative distance? In very simple word, I call administrative distance as trustworthiness. Okay, trustworthiness in the sense, if I do have these protocol listed up, okay, which among them is most reliable or which is very trustful. Okay, so basically we know a static route is always manually configured. So if in case I have configured it manually, that means I should consider this as the most trustful routing protocol. Agree? So this will win the election. Okay, so the static has a administrative distance of 1. Similar way, eBGP, or let's say iBGP, will have the highest AD value, that is 200, and it's considered to be the least trusted. Okay, so it's nothing but the trustfulness of the routing protocol. Okay, administrative distance is something which is used to select the best path between two different paths to the same destination over on the two different routing protocols. And it defines the reliability. Even your IP6 V6 is going to make use of the same distances. Okay, and these are some predefined AD values based out of the protocol that we use normally. Okay, so in a practical scenario, let's say I have this router which can take either of the path to reach this one, 4.4.4.4. Let's say I defined a static route here. Okay, so what was the first tiebreaker? /24. So let's make it as all /24. Now longest match is not going to be helpful for me. Okay, now let's talk about the second criteria, that is I have static configuration, I have iBGP configuration, and I have OSPF configuration. Okay, and from this router point of view, which path would be selected? Okay, now since the first one doesn't hold valid, now since I have three different routing protocol, I must refer this table. Okay, so for a static routing protocol, I have the AD value of 1, so I'm going to put as 1 here. For iBGP, which is 200, and for OSPF, it's going to be 110. Okay. So which is the best path? The static route would be the preferred path. The second preferred path would be the OSPF. And the last or the least would be the IBGP. Okay. So this is about the trustfulness of these routing protocol. Okay. So this was the second criteria for the router to make the decision. But let's say they are all running on the same protocol and the same AD value. Let's say I need to send something to 4.4.4. All of them are /24, and now they are running the same protocol on every router. Now, do you think my first and the second criteria is going to hold good? No. So I need to have the third important thing. The third important thing here is metric. Okay. Metric in other word is nothing but the cost value. Okay. So the cost value can be different among this. The reason is, let's say over on this, even though they are running on OSPF, they might be running on a serial link, right? Might be this OSPF is running on a Ethernet interface, and this might be running on Giga Ethernet. Now, cost is important in this case because the first two criteria are same. Okay, but if you see the link bandwidth, now you do not want your packet to take the serial link at any cost because of the speed of serial link, right? So what is the speed of the serial link? It's 64 kbps. And what is the speed of giga? It's 1 gbps. What is the speed of fast ethernet? It's 100 mbps. So do you want your packets to be taken up on the lowest bandwidth link? No, right? So in this case, the cost plays an important role, and the cost will be calculated based on this medium. Okay, so let's say on the first path, which is serial link, we have a formula in case of OSPF. Is called as reference bandwidth by bandwidth. Okay, and reference bandwidth is 100 mbps in case of OSPF. If you divide this with the bandwidth of interface, so let's say 64 kbps, so you're going to get some value. Okay, I'm not sure what value you're going to get, but let's see. Let's take an example. It's 19. Okay, now in the case of second path, where reference bandwidth is once again 1000 mbps, and it was a fast Ethernet, or let's say it's a Ethernet only. Okay, it's a Ethernet interface, which is 100, which is 1 mbps. Now you get 10 as the cost. And in the case of the last link, which is Giga Ethernet, you have reference bandwidth by Giga interface. Okay, 100 mbps with 1 gbps, which is some decimal value, but we cannot have decimal value, so we should approximate to the 1 count. Now, from the cost value, as I told you, if something is traveling from A to B, so which one would you take? The one which is having the lowest cost. So which is having the lowest cost? It's your Giga interface, right? So these are the three criteria for the path selection. One is longest match, AD value, and then the cost value or a metric value. Okay. So basis on these three factors, the router will make the decision on forwarding a packet. Okay. And yes, there are something called as equal cost path and non-equal cost path. That means, like for example, I'm talking about OSPF and EIGRP. Okay, so let's say I have router 1 connected to router 2, router 3, router 4. This is going to connect to the router 4. Okay, let's say this is running on serial link, so out of our league. Okay, and the next two are running on Giga Ethernet. Now both are best path, right? They're having the same 1/24. They are having the same OSPF, so they are going to have the same AD value, which is 110 and 110. Now both the criterias are matching up. Now the third criteria was metric. In this case, metric is also a type. Now in such scenario, in your routing table, you will see OSPF showing up two links. Okay. Now these two links are going to help us on load balancing. Okay. So what does it prove? OSPF supports load balancing. Okay. So how do we see such routing table are? So something like this. Okay. You will see two routes to the destination. One over on this interface, second over on this interface. The reason is you're having the same cost. Okay. So OSPF is going to support. OSPF and EIGRP both are going to support you equal cost. Okay. Now what it does is like how in your Ether channel, when let's say I had only 1 gigabit per second link, if I add up one more and I just bundle it, what is the total value? It's 2 gigabits per second. Now in this case, the same thing happened. Okay. It's load balance or load sharing, not load balancing. It's load sharing. Okay. So your OSPF and EIGRP will support equal load balancing. Okay, that's something good thing. But there is something called as unequal cost load balancing. Now EIGRP will help you to achieve unequal cost load balancing. Okay, so if you see this diagram, you have two different paths to reach this destination. Okay, with different cost value. One is 3328 and one is 5632. Now what you can see over in the routing table is you can see both the routes have been entered, or both the routes have been put up in the routing table. Okay, with a different metric. So do you think the one with highest metric, basically it's a low link, that's why it's having highest cost, and this is a better link or with a high speed? Okay, so let's just take it as 1 gig and let's take this as 100 Mbps. So do you think we can make equal sharing, that is 50% going to the first interface and second going to 50? That's not the right way in such scenarios, right? Because they are two different Ethernet mediums. So what I can do in EIGRP is I can set a ratio. I can set, let's take 70% of traffic on the first link and let's take 30% of traffic in the second. Now that's called as unequal distribution of load, but it's supported in only EIGRP. Okay, not in OSPF. By default, it's not, but we have to manually configure unequal load sharing. We will do this in a practical. Okay, fine. The last topic here is static routing. So basically there are, okay, now what is static routing? So let's say that I have couple of routers. Okay, I just don't want to enable EIGRP or OSPF or RIP. Okay, so in case if I would have just enabled, they would have sent their components or hello packets. They would have formed neighborship and all our networks would have been properly synchronized among all of them. But in the case of static, there's nothing happening dynamically. We have to manually define. Okay, let's say if I have this router connected to this and I have this router and this has some networks. Okay, and I just want to distribute, or I just want to achieve a basic ping, or I want to send some file to this person. Now I could have made use of dynamic option, but I'm saying that I'm not going to make use of this. So the other way left is only static routing. So what I do is I just say anything to send across to this destination, I can either make use of this interface. Agree? I can say to reach 1.1.1.1, the packet must go over this interface. Agree? That is one thing that I can do in the case of static routing. The second situation is, instead of mentioning the interface, I can say that take this IP. Now let's say this IP was 2.2.2.2. I can say if something has to reach to 1.1.1.1, let's make or let's send it to 2.2.2.2, and the packet will then be sent across. Okay, so manually we are placing the command. These are manually configured, but the drawback of these kind of uh, manual configuration are they are uh, they are possible only if you have 20 to like 30 manual configurations. Okay, in case you have like more number of users, more than 50, more than 100, then it becomes little mess up because you have to manually configure the routes, you might have to delete them. Okay, so it depends. If you have very less user, you can go with static. You will have more in-depth knowledge, like on which user you have allowed the routing. You can like manage the routes. In case of static, you can delete it, you can add, you can manipulate, you can do anything. Okay, in case of dynamic, you will not have a lot of control in such scenarios. But when it comes to the number of counts of configuration, now that's where you just cannot go with static. You have to go with one of the dynamic routing, either OSPF or EIGR. But let's first see static, and then we will go ahead with the next few things. Okay. Yes. So regarding to type of static, there are three ways. Okay. So as I told you, if I have two routers or like three routers, either I can configure a static route over here on R1 that to reach 4.4.4.4, make use of this interface, and so on. And then this router will say, make use of this interface to go and reach the destination. Now that's called as directly attached static route. Okay. When you are defining a static route basis on interface, you're calling it as directly attached static route. A similar way, let's say I have the similar kind of network diagram. Now to reach 4.4.4.1, okay, you are just focusing on this IP, not on the exit path. Okay, and let's say the IP here is 2.2.2.2, and similar way this router is pointing over on this 3.3.3.3. Okay, now this kind of static route configuration is called as recursive static route. Why do we need recursive static route? Is, let's say for some reason this interface went down. Okay, let's say you configured static route on the basis of individual interface, and for some reason this interface is down. Now your whole static route is down. Agree? Because you set manual static command on the basis of interface. Now if the interface is down, it doesn't make sense. It will not find out any other way. But in the case of recursive static, we are focusing on the next hop IP address. Okay, so the chances are that, let's say, this router also had a connection with one of the switch, and the switch was connected back to this router on this interface. Let's say my static route, which says that any traffic to reach 4.4.4.4 must take this IP 2.2.2.2. Okay, now there is chances that might, even though my this interface goes down, it still takes up this path and reach to this. Okay, because this is going to be valid. I'm not going to configure it based on interface. So the interface health is not going to make any sense for me in this scenario. Okay, so you got the difference, right? In the first case, it's on the personal interface that you're pointing your packet out. Now that's called directly attached static route. In the case of recursive, you're not going to mark the interface. Instead, you're going to mark the next hop IP address. Okay, so it doesn't matter how you reach. If you reach to this, it's going to do the job. Okay, But there is a problem now with the recursive. In case the second outgoing connection, it's not going back to this router. Instead, it was connecting to a different router. Now, recursive is not valid. Okay. Now, in this case, recursive is not valid because there's no way this router is going to go and connect back to this. So might be this is going to some other direction, and now the recursive is not valid. So the condition for recursive is, or the case when recursive is going to work is when the outgoing interface is still going to the destination, okay, over on this IP. Okay, let's say if this primary interface went down, you still have second interface which is connecting to this router. Okay, and due to the routing table within that, it still have a chance to reach destination. But in the case this outgoing interface was connecting to a different router, now there is no way the recursive is going to help. Okay, so that's something uh, different in case of a static, in case of recursive. Now what is fully specified static route? Now that's when you configure both of them. Okay, we're going to configure the interface as well as the IP. So that's the case when you achieve full specified routing. So let me show you the diagrams here. So in the case of directly attached, okay, like as for in this example, you're just marking your own interface. Okay, IP route. So so the traffic flow is in this direction. Okay, so on router 1, you are just setting a command saying to reach this IP, you just are sending from this interface. Okay, now that's an example for directly. And similar way, you have to configure a return traffic, because the traffic which goes in one direction must know the return traffic as well. So on the router 2, you just configure back. Now in this case, to reach this destination, take this interface IP. Okay, so that's way you are going to achieve the outgoing and incoming traffic in the case of static configuration. And this is an example of directly attached static route, where you are giving up, or where you are configuring based on the interface numbers. Okay, the next type of static that we discussed was recursive. So in the case of recursive, I am not going to make use of interface numbers. Instead, I'm going to make use of the IPs that's configured there. So let's say on this, I have 10.12.1.1, and over here I have 10.12.1.2. So from R1 point of view, okay, from R1 point of view, to reach this destination, which IP am I forwarding? I'm forwarding to this, which is 1.2. Okay, 1.2. Similar way, the return traffic, that is from this point of view, to reach this destination, which IP am I forwarding? I'm forwarding to this. Who is forwarding? This R1 is forwarding now. Okay, 1.1, 12.1. Okay, so looks like there is one missing bit here. Okay, so that's recursive, where you're going to take up the IPs. The commands are very similar. The same command, it's IP route, destination network, destination subnet mask, and either you can set the interface number, or you can set the next hop IP address. Okay, so you have this with you. You can set whatever you want, but the commands are same, and most of the time we just call it as static route only. Okay, we just call it as static route. But since we are learning in depth on this, that's why these three types have been introduced. Okay, the directly connected static route, recursive static route, and the last one, that is full static route. What is the disadvantage of the first type? It's when, let's say, this interface goes down. Let's say this interface goes down, now the whole static route is lost. Okay, so that is why your recursive is going to help you. In the case of recursive, let me show you. Okay, so in the case of recursive, if the link fails, you still have the static route installed in the router, isn't it? You still have the static route. Now, let's say that router has a different outbound interface. Let's say the other interface, other outbound interface in the same direction. Okay, in the same direction, 4.4.4. Now that's can be possible, and which can help you the recursive routing or static routing to be functional in such scenarios. Okay, so that's an advantage of recursive. But disadvantage is, let's say if the outbound is not pointing to the similar direction, or it's pointing out in the opposite direction. Okay, now that can lead to your static route failure. Okay, to correct that issue, we have the third and the last static route type, that was called as fully specified static route. So in this case, what you do is you have to mention both interface along with the IP networks. Okay, command is again very similar. IP route, the destination IP, the destination network, the prefix length of destination. This is the source network or the source interface IP, and this is the gateway or the next hop gateway. Okay, I think we are almost done. Okay, just last two things, and then I'll take Q&A. Okay, regarding to the floating static routing. Now this is in the case. Let's say we have two static routes to the same destination. Okay, let's say one of them is on serial link, and for some reason this is getting considered. Now what you can do is you can set some AD value. Now this is interesting thing. You have heard the AD value from the point of different protocol, like static has its own AD value, OSPF has its own AD value. Now let's say this is only about static routing. Now static routing can have multiple ADs getting configured, like something in this case. Okay, so and at the end of each static route, we can just write some AD values. Now the lower AD gets selected up for the routing path selection. Okay, now let's see in this example. In this example, there are two paths. One is serial path and one is giga path. Okay, so for some reason, the router 1 R1 was preferring this path to reach the destination. As we know, as we see, this is a serial link. So what I can do is I can put a higher AD value behind of this static link, and at the and for this static route I can prefer a better AD value. Now this is in the case of primary, and this is in the case of secondary. Let's say if primary goes down, you still have the second one acting up. Okay, so that was a main purpose of dynamic routing protocol also, right? Why we use dynamic is, if primary goes down, I still have the secondary automatically coming up. Okay, now like if you thought that dynamic is going to help me for redundancy, and static is no longer going to help me. Now this is something where you can have redundancy also. Okay, so your static is also going to help you in case of redundancy. So that's defined over here. Okay, now again the same command, just change the AD values, and if you see the show IP route, so you can see the best path would be taken up with the shortest AD value. Okay, so this will be not put up in the routing table. So that's called as floating static IP or floating static routing. Okay, and the last topic here, that is static null routes. Now you might have seen some routes with null zero. Okay. So the speciality of null zero is to drop the traffic. So let's say if it was about to drop the traffic or to not forward the traffic, okay, then why do we need to point some routes to null interface? Okay, so let's take as an example. Okay, let's take as an scenario. So let's say I have a company ABC. I have my ISP here. Okay, so ISP and my company ABC are on this static route, and within my company I'm going to make use of some private network, or let's say some public network. Okay, and let's say this is a public network. So for some reason I just have borrowed a lot of IPs. This is in 255, 255, 240.0 subnet. Okay, I just have borrowed the whole thing for my future use, but out of this I'm just using one subnet, second subnet, and third subnet. Okay, so out of like couple of IPs, I'm just making use of few of them. Okay, so now what happens is, let's say someone from internet, if he tries to ping 172.16.5.1. Okay, now what ISP is going to do is, since ISP is having a static route for this whole network forwarding to R1, so it will think that 5.1 is a part of this network or this whole broad network, so it's going to send to R1. And since R1 is all connected to the 3.0, 1.0, it's also having some static route. Now that's going to be forwarded to R2. Okay. Now what R2 is going to do is, R2 is going to check if there is something for 5.1 and it doesn't find something. So now what it does is, it's going to send back to R1 saying that I do not have anything. So just sending you back. Now what R1 is going to do, R1 is trying to send that packet out of this to ISP. And now what happens is, this traffic gets looped. Okay. So there will be some looping happening over here in the such scenarios. Okay. So this can be proved over on lab also. We can see the loops, and after certain TTL values, time to live, the loops will be getting over, and whatever ping or whatever trace that was initiated will be getting expired. Okay, that is fine with the loop. In case of layer 3, or in the case of routing loops, that's not very risky or not very dangerous, because they come with TTL value. The maximum TTL can be 255. Okay, and as per the platform, the TTL can be 64, 32, whatever. So at certain time, or after certain packets, they will of course get expired. It's not like your layer 2 looping, which is endless. Okay, in case of the layer 2, they are endless, and what they're going to do is, they're just bringing down every hardware. In the case of routing loop, they are coming with TTL values. So at some point, or after like 255 packets, or after 10 packets, 20 packets, the loops will get removed off. But the issue is, the overhead on these two routers will be increased because of the looping. Okay, so the main thing for me is R1, because I am not going to control ISP router. ISP will be taken up by ISP team. So from my side of view, my router R1, which is a core router, will have a lot of overhead. Now what I would prefer is, I would put all this broad list towards null. Okay, I will put this whole network in the null interface, towards null interface. Now if something comes apart from these network, okay, my router is going to point it to the null. And what is the property of a null interface? So null is always up. Okay, they are never going to forward. They are never going to receive anything. They are all going to drop the traffic. Okay, so your loop will not occur. As soon as something goes to null, the packet will be dropped. Okay, so that's an advantage of keeping null. So this was one scenario of using null. But yes, if you talk from the BGP point of view, BGP null, there are different reasons for BGP null. Okay, like for example, BGP, which has a requirement that it must read the routes only from one of IGP read route. Okay, let's say if some route or some network is being learned via these, then only those are eligible for BGP. If it is not learned by any of them, then the BGP will not consider those network. They are going to drop. So in such case, what I do is I just don't want to increase overhead on these individual protocols. So I just put those network towards null. Okay, so what it basically is doing is it's a static routing, right, which is one of IGP, and now BGP will learn these networks. Okay, it's scenario when you don't want to advertise a network on IGP, but you want to advertise it on BGP. Okay, so you just don't want that network to be advertised IGP, but at the same time you want it on BGP. So what is the solution? You just point that network to null zero interface via static routing, and then that will be learned on or over BGP. Okay, so it has different ways or different types of uh, reasons to be used. Okay, so as I told, they are not going to forward anything. Okay, they are just going to drop. But it's as good as configuring static route, which is an example for IGP. It's used for preventing routing loops. Static route to null is used for summarization. Okay, and yes, these are some steps that I just discussed, the scenarios, and these are the configurations. Okay, so yes, we can do this. So give me just 5 to 10 minutes. I'll just show you what I'm trying to do here. So let's say I have ISP here. Okay, and this is my company ABC. So let's say I'm on 192 series, and over here I have 172 series, and I have just borrowed up some huge IP networks in 172 dot slash 28 or 26 network. Okay, so all of them are on a static route. Now there can be looping happening. So I'll show you what kind of loopings. Okay, so I think I have configured over here. So let me show you. Okay, so let's say from my router 2 point of view, that is this router. Okay, so from this router point of view, if I try to trace route one of the IP like 172.16.0 dot something. Okay, now what happens is it will be pushed to R1 will push it to the ISP router, and since it already has a static route back to R1, now they are going to form a loop. And how does a routing loop looks like? So this is this is called as a loop. Okay, so what happened is when you just triggered up some traceroute packet from R28 to 5.1, okay, it went to 1.1. Now 1.1 is over here. Let me just redraw. Okay, so your packet first hit on this interface, which is this 1.1. Once the packet was received onto R27, R27 pushed it to 1.2. Now 1.2 is nothing but this one, 1.2. Now what happened? 1.2 had a static route facing facing back to R1. It again sent back. Okay. to 1.1, 192.168, 1.1. And now they formed static, or they formed the looping. Okay, you can see the packets are just going among these two routers, between ISP and between the router 1. So what I do is I just configure a null. Okay, so let's say I just configure one of the null, and again it's similar way that we configure any static route. Okay, so the whole wide network 0.0 on dot 250.0 is pointing to a null 0, which is a virtual interface. Okay, if I just press enter and if I go back to this router and if I do trace route, okay, looks like there is something been taken out meanwhile. Okay, so if you see now it's been broken up. So what happened is, it from this router it went over to this, and since this is pointing to null, what is null going to do? Null is going to drop it. So the null will not forward it back to ISP and there will be no looping. Okay, it just send it to 1.1 and then it was sent to 1.2, and that's all. That's the end of the loop here. So that's why your static null will be used. Okay, so over here, so that's about static topic, static routing. Okay, so what I'm going to do is I just want to give you some basic assignments. Okay, so let's say I have three types of static routes, that is directly and recursive, and the last one here was fully specified static route. Okay, so the commands are already given, but yes, if you just want to practice it, try to configure static route. Okay, just make use of static route. Don't Okay, so as I was telling, make use of only static route. Don't make use of OSPF or EIGRP. Okay, try to configure. Don't refer this, because whatever we covered today was just a basic of CCNA or just little bit extra than CCNA. Okay, so try to configure OSPF, try to ping from this end and also try to ping from this end. Okay, sometimes you can ping on one side, but other side it won't be because of some issue or some kind of route issue. So you need to fix it out. Okay, so there are three types of routing. I have already given you the lab commands, and regards to the null, yes, you can also try to do it. Okay, the configurations are discussed here. And regarding these three path selection makers, okay, so these I can show you in the next class, that is longest match and AD value and metric. So again, this is very simple. I just don't say you to wait till Monday. You can of course do this and you can try out yourself. Okay, But yes, if someone for someone it's something like on a tougher side, then I'll do this on Monday. Okay, I will show you how the decision maker or decision happens in case of routers or in a routing technology. Okay, and this equal cost and unequal cost, don't try to do this. Okay, because these are protocol dependent, so we will discuss it when we are covering up protocol, and rest were all theory topics. Okay, fine. So I'll pass on this document along with the video. So yes, let me open up for Q&A. So if you guys have any questions, please let me know.
No questions.
Okay, so guys, yeah, you can unmute yourself. So let me know if you have any doubts. So any doubt on the topic that we discussed today? Something that you want me to repeat in the next class? Yes, no, no response.
I'm good, Saka. I'm good with everything.
Okay. Okay, so regarding the full static specific route, okay, so yes, it works in the ASA firewall. Okay, so guys, if I just see your Q&A, I
have
guess.
a question for
Hello,
you.
yes.
So, can you explain me about that hardware and software of in terms of router and switches? I know switches has some A6 processor. It makes more faster and to compare with router.
Okay.
So, explain me about that. And
So I guess you
so
have not.
was
I guess you have not gone through the previous videos, because this is already discussed, the ASIC and the routing processor. So you basically go to the video number. Let me tell you. On the class 2 packet flow in switch router, the control data plane management plane. So this video will give you the answer.
okay.
Yeah.
So you mean this what do you call FIB will work on which it's in hardware or the software? It should be in software, isn't it?
It is a special kind of chip which is in the processor. So that is what
So
you, yeah, you check that video. It's along with the slide presentation. So we have discussed by taking all the diagrams and all those things.
So the FIB FIB should be on a software. Okay.
So sorry, which one?
FIB, forwarding information base.
Yeah, yes.
So forwarding information base and routing information base all in software.
Yes.
Okay. Thank you.
Okay.
Hey, Saka,
Yes.
I have a question. So, say if you have computer A and computer B, and you write a static route stemming coming from computer A and going to computer B. Is it necessary for you to write the static route on both routes? If I just want computer A to go to computer B, like say for example, if I
So are you talking about two opposite routers?
yes, two opposite routers,
No.
and I write a static route.
No, in this case, you don't need static route. Let's say if you have 1.1.1.1 and if you have 1.1.2, you don't need static route.
Yeah, no, okay, I'm sorry. You can add a third router.
Yeah. If in case you have another router here, which is on 10 dot network. Now this is where you have to write the static route, because that's how your routing table will know the second network, and that's how the packet will be processed.
Yeah, so do I have to write the static route on the opposite end also?
Reverse, yes, you have to. So let's say if you have to communicate from this on something which is behind this, like 10.1.1.1. Now you need to write a static route to reach this.
But what if I only want it in one direction, from router 1 to router 3?
Okay.
Do I have to write a static route on R3 also?
Okay. See, let's take it as this point. Okay. So let's take it as this point. So basically, if you have direct reachability, okay, and let's say if you're trying to ping this, so your packet will first go over here, and then it will check the routing table information, and it just will come here. Okay. But for the written traffic on this routing table, there will be no information about this. Now your traffic will get discarded. So you need to,
Why is this?
yeah, so you need to have a static route, so to have to define the process.
So basically, okay, I see. The route has to be just like kind of like BGP. The route has to be in the routing table.
Okay, so if your question is where exactly to put the routing, so you can enable routing on these two. Okay, and since these two are already directly connected to router 2, so router 2 will basically know router 3 and router 1, because they are directly connected. So you have to enable static route on these. So from R1 point of view, you need to write a static route to reach something on this side. And from R3 point of view, you need to write a static point to reach R1 in this direction.
All right, but what if I don't want? What if I don't want R3 to reach R1? I could still write one static.
So you just need R1, R2, R3.
Okay.
Is that your question, that you need only R1, R2, R3, but you do not need R3, R2, R1? Is that your question?
Yeah. Yes, sir. Because I see.
Okay, so yeah, so you can just place the ACL on one side only. I mean, you can just place a static route on one side, on this side, that is R1, R2, R3.
Okay. And the ping will work.
Yes, the ping will work.
Okay. Thank you.
Okay, and yeah, one last thing about before winding up the class regarding the web portal. So let me tell you how exactly this web portal work is. So let's say whenever you get some instruction to or whenever you get some videos put up here, so basically when you click on that link, you see some kind of instruction here. So you just need to click here, and the user ID and password will be already given to you. So in my case, this is my user ID, and I just go and enter my password. So, but I would prefer remember me option, because I don't have to redo this step again and again, and then I'll click on login. Okay. So once I click on login, it will take me to the next page where the content would be password protected. Something like this. Okay. Now the password is something which is given in the step number 5. So just copy this and paste it over here and click on submit. So once you submit this, you can watch the content of this particular class or something. Okay. So I have seen people are trying to paste the password which we used in the first step. Okay. So there are 2 different passwords. First with the email ID and the second one is just to watch the content. Okay. Fine, guys. So let's meet up on the Monday. Okay. And have a nice day and have a nice weekend ahead. See you soon.
You too. Thank you.
Okay. Thank you, everyone.
Thanks, Saga.
Okay. Thank you.